Hey, it's Mrs. Hoekstra. I hope you are having a good week and had a good weekend. The exciting thing is this is going to probably be a pretty short lesson. You will have to stop and pause every so often to do a little bit of work and then go ahead and hit play again. And I will be able to give you the answers after you've worked the problems out on your own. All right, so lesson 3.3, ordering and exponents. Okay, ordering and exponents. So we're going to talk about greater thans and less thans. Yay! Now, I don't know about you guys, but when I was a student, when I was little, I really did struggle with the greater than and less than symbol. And the whole thing about being told, like, oh, well, the alligator always eats the bigger number and all that never made sense to me. Or it points to the bigger number. No, it actually points at the smaller number. Okay, so we do have the term of less than, okay? But I also want to kind of refresh your memory on maybe a different way of looking at what the inequality symbols are. So for example, less than, since that's what we're talking about here, less than, I want you guys to check this out. I had a student taught me this. One dot is less than two dots, and then you just play connect the dot like that. Less than. One dot is less than two dots. So if you have a student maybe who's struggling with this idea, you could say, well, which one's smaller? And tell them, put a one dot by the smaller one and put two dots by the bigger one and then play connect the dot. And then they get the right symbol. And eventually they'll start figuring this out. So we've got the less than, and then of course we also have greater than. Right? We have greater than, and again, two dots is greater than one dot, and you could play connect the dots. Okay, while we're talking about ordering, we have less than and greater than. There is also the greater than or equal to, or the less than or equal to, right? They've got the lines under them, right? That just adds the or equal to part of it. Okay, greater than or equal to, less than or equal to. So let's read the definition of less than. For any two whole numbers, A and B, where A is less than B or B is greater than A, because again, you can read it backwards, if and only if there is a non-zero whole number, N, such that A plus N equals B. In other words, you can always add another number to A to get to B. In other words, you have to add something. There's additional things that have to happen in order for you to get to that B point. All right, the transitive property. Okay, now this is for less than. All of these would also work for greater thans if you wanted to like flip the way it works. Okay, transitive property. For all whole numbers A, B, and C, if A is less than B and B is less than C, then A is less than C. Okay, so you're like, let's take a look at that, right? So if A is less than B, right? Look at the number line. A is less than B, and B is less than C, then by transitive property, A has to be less than C. Okay? If we maybe put an example over here, and we say 3 is less than 5, right? I could put a 3 here, and I could put a 5 here. Don't worry about the number line not matching up. That's not the point. 3 is less than 5, and we know that 5 is less than 7. 5 is less than 7, right? Then we know that 3 must be less than 7. And sure enough, you can see that it is, right? On the number line, you can tell. Transitive property. All right, less than, again, it also works for greater than, and the addition property. So if A is less than B, then A plus C is less than B plus C. All right, let's draw a number line. Let's draw a number line. If A is less than B, then A plus C is less than B plus C. So let's draw a number line. And let's put an A. And we're going to add C. I have no idea what C looks like. We're going to add C. Right? So this line here represents A plus C. However long C is, we don't know. And then we have B. B had to be bigger than A, right? So we'll put a B out here somewhere. We'll put a B out here somewhere. It could have been even in between the A and A plus C. We don't know, but we're just going to put it out there. And we're going to have to add C to that as well. Right? And that new spot is B. Oops, B plus C. Okay, it is still very obvious that A plus C is still less than the B plus C because it is further to the left, right? It is further to the left, so therefore it's smaller on the number line because we understand how number lines work, right? They get bigger as we go to the right, and they get smaller as we go to the left. Okay, same thing for multiplication. Right? Same rule applies for multiplication with two exceptions, So if A is less than B and C does not equal 0, then A times C is less than B times C. Also, we know that C cannot be 0 and C has to be greater than 0. In other words, we're talking about it has to be positive. Now, most of you, when you teach, are going to not be teaching with integers and having to deal with that. But as we get older, we have to actually throw that into the problem. If you need an example of what I'm referring to, right, let's pick some numbers for A, B, and C. So A, we'll say, is 7, B, we'll say, is 10, and C, we'll say, is 2. Right? And let's plug that in. So we know that 7 is less than 10. That's a true statement. So 7 times 2 has to be less than 10 times 2. And can we prove that? Sure. 14 is less than 20. So yes, there's one example. Now, just because I'm showing you an example doesn't mean it's always true. You'd have to go through and do some proofs. Remember proofs from probably geometry class, right? Proofs for algebra is a little bit different, but you kind of have to do the same thing where you have to make it so it works for all problems, and you have to use variables. All right, any questions about ordering that you may have, you're going to have to shoot me an email. But again, all these ordering properties are true for greater thans as well, right? It's just going to be slightly different. Hey, this one's greater than that one, and so on and so forth. All right, if you're good with that, I'm going to move on. If not, keep writing some more of your notes and hit pause. All right, let's talk about exponents. Okay, let's talk about exponents. In fact, I'm going to move some of this around so I have a little more room. All right, let's move this a little bit. So an exponent, right? An exponent is basically talking about repeated multiplication. That's what this example shows here in a minute. But I want you guys to understand when I use different vocabulary, you're going to have to understand exactly what the vocab that I'm referring to. So the vocab, right, if we have A to the M power, A, whatever this bigger number is, this is called the base. Okay, and the base gets multiplied. Okay, gets multiplied. Ooh, L-I-E-D, there we go, multiplied, gets multiplied. And the M, in this case, it's raised up, right, is the exponent. And the base gets multiplied, the M is the exponent, and it tells me how many times to multiply the exponent, or I mean the base, excuse me. Indicates number of times the base multiplies itself. Okay? That's basically what you need to understand, and I will be talking about bases and exponents, so make sure you understand those vocabs. So based on the definition, let A and M be any two whole numbers. This is working for whole numbers. We're not going to deal with fractions. Okay, that's high school. Where M does not equal 0. Okay, so we're referring to M being an actual number other than 0. When we deal with 0, I'll get to that in a moment. Okay, then A times M is A times A times A times A times A times A, M number of times. M number of times. Okay, so think of multiplication as repeated addition, right? We talked about that. So exponents is repeated multiplication. All right, let me give you an example. Okay, let's get an example. Let's do 3 to the 5th power, right? So that's in exponential notation. It's in exponent notation because there's an exponent in it. So if I said put it in expanded form, 3 times 3 times 3 times 3 times 3, right? There are 5 of them, right? There are 5 of them. That's where that came from. And the 3 keeps getting multiplied to itself 5 times. Okay, so that's the expanded form. And then when you give me the answer, right, when you give me the answer, then you finally end up with the actual standard form is what they call it. Okay, so if I multiply this out, I should get 243. You probably have a button on your calculator that would help you with this. So it's probably going to look something like an X to a Y button, maybe something like that. Or you'll have a caret, right? You'll have a caret button. Depends on the type of calculator you have. If you have caret, you would do 3, you would hit the caret button, 5, and then hit equal. All right, if you have the XY button, you would hit 3, this XY button, 5, and then equal. All right, so depends on how your calculator is set up as to which button you would have for that. Now there are some crazy, weird exponent rules. All right, the rules that I'm going to show you, most all of them, you have to have the same base, except for one. Okay, and I'll let you know when that happens. Have the same base. If they don't have the same base, the rule won't work. Okay, but in order for the exponent rules, they have to have the same base. So one of them is when you multiply. Okay, when you work with multiplication, the rule says that if you have a to the m power times a to the n power, what you're going to get is a to the m plus n power, whatever that equals, right? You're going to take those two exponents, add them, whatever that sum is, that's your new exponent, okay? But it has to have the same base, okay? Then you also have powers. Okay, if you have a power, you have a power to a power. You have a to the m power to the n power, right? A to the m to the n power. When you have that, you actually are going to have a to the m times n power. Okay, you're going to multiply those two. And then we have division. And when you have division, division is a reciprocal of multiplication. Multiplication we added, so what do you think is going to happen with division? Division, we're going to subtract. A to the m divided by a to the n is equal to a to the m minus n power. Okay? Now, because we're only working with whole numbers, you're probably not going to see the integers and deal with those. We'll get with that later. Now remember, these rules all have the same base, except for one that I need to make sure you guys catch. Okay, this one, they don't have to have the same base. And it is a multiplication problem. Okay, it is multiplication. And the rule is this. We have a to the m power times b to the m power. So in this problem, they don't have the same base, but they have the same exponent, right? They have the same exponent. If that's the case, we can actually still deal with it. All right, if that's the case, we can say this is a times b to the m power, okay? We can multiply the bases and leave the power as is. You don't change it, you don't do anything else with that. All right, those are my exponent rules. So what I would like you to do is to write down the next two problems here. And then what I want you to do is pause the video, do these two problems and see if you get the same answers I do. All right, go ahead and hit pause. All right, so there is my work and my answers. So for A, I got 2 to the 7th power. And for B, I got 3 to the 12th power. If you didn't get that, notice what my work is compared to yours. Fix it if you need to, obviously. And let's keep on going. Let's try some more. All right, I'm going to change my screen here. All right, so again, we've got 2 more problems up there. I want you to hit the pause, work on those 2 problems that are there, and then hit play and see if you have the same answer as me. Okay, so there are my 2 answers. I ended up with, for A, 10 to the 3rd power, and for B, I ended up with 231 squared. All right, I'm going to show you guys really cool multiplication tricks eventually and how to figure out the 11s without needing a calculator when those numbers kind of start to get bigger. All right, we've got 2 more. Rewrite the following as a single exponent. Rewrite those as a single exponent. Again, hit pause and see if you guys get the same answer I do. Okay, so for A, I have 5 to the 6th power because you're just going to multiply a power to a power. And for part B, I'm going to have 7 to the 32nd power. Again, 8 times 4, 32. All right. 2 more. Go ahead and find the answers to these 2 division problems. Hit pause and check your answer with me. All right, and for A, I got 5 to the 4th power, and for B, I got 7 to the 3rd power. Hopefully you do remember these from way back in the day when you're in high school. Now the one crazy weird exception, remember we've said that these numbers had to be whole numbers, and they basically had to be positive. The one exception is for when the exponent is 0. And sorry about this. Any number that we have raised to the 0 power is always 1. Always, always, always 1. Okay? That is the rule for any of them, and we've kind of talked about that and alluded to that when we were working with the different bases. All right? So that's the one kind of weird exception. All right, I'm going to change my screen, and we've got 1 more problem to go. All right. So, order of operations. Woohoo! Order of operations. My guess is most of you probably know, please excuse my dear Aunt Sally. There are other ways you could have it. Most of us just do that, or we just say PEMDAS. But you could also say purple elephants may destroy a school, right? As long as you just have some kind of weird mnemonic to help you remember this. So P is for your parentheses, right? These are your parentheses. You're going to do those first. Parentheses, and then you're going to do your exponents, whatever that little exponent is up in the top. Then you're going to do multiply and or divide, and you actually do those from left to right. So if you have only multiplication and division left over, you work from left to right, and then you have add and subtract. Again, if that's all you have left, you work left to right. Okay? So I'm going to ask you guys to pause and do parts A and B, and then I will come back on and see if you and I have the same answers. I am going to show all of my steps all the way through. So go ahead and hit pause now. So my answer for A, I got 89. All right. Worked within the parentheses, then I dealt with the exponents, then I multiplied, and then I subtracted. Now B gets a little trickier because you don't have all the parts. So you have to start with multiplication and or division. You work across. So it does end up being 4 divided by 2. 4 divided by 2 is 2. 2 times 5 is 10. So 11 minus 10 is 1. 1 plus 3 is 4. Okay? I believe that is all that I have for you guys. So on Thursday, we will have our test, And hopefully you guys are doing okay with the review that I have given you. I hope you guys have a great rest of this week, and I will see you on Thursday.